Hello, welcome to week 16, chapter 11, lesson 5. It is about probability. At the end of this lesson, you should be able to compute empirical probability, theoretical probability, and also you should be able to find the probability of an event that will not occur. Now let's see the lesson content. So in this week we are going to discuss about empirical probability. We will see what's empirical probability and how we evaluate or compute empirical probability. And also we are going to discuss about theoretical probability. We'll see the formula that help us to find theoretical probability of an event. And then we will see the relationship between combinations and probability. As you remember, we discussed about combinations in week 15. So we are going to see the application of combination in this week. And then finally, we are going to discuss about probability of event that not occurring. As usual, at the end of the solved problem, you need to uh, practice a checkpoint question from your textbook. Now let's go to our first point, which is about empirical probability. Empirical probability applies to situations in which we observe how frequently an event occurs. To compute an empirical probability, we are going to use this formula. So the probability of event equals to observed number of times it occur divided by total number of observed occurrences. Now, based on this formula, let's practice an example computing empirical probability. Example 1, there is a data given about mammography screening on 100,000 US women, age varies from 40 to 50. So as you can see, the data displays about the number of breast cancer patients with their respective positive and negative mammography screening, and the number of patients with no breast cancer with their respective mammography screening result. Now, based on the given data, we are going to answer part A, B, and C. Let's start with part A. Use table 10.4 to find the probability that a woman aged 40 to 50 has a breast cancer. So from this question, what we understand that we are going to choose a woman with breast cancer from the total number of women uh, from the data. So as you can see, the mammography screening is taken from 100,000 USA women. So this is the total sample that we have. Then we are going to choose or we are going to find the probability the woman with breast cancer. So the total number of patients with breast cancer are 720 plus 80. So this is the total women with breast cancer. Therefore, it will be 800. So 800 divided by 100,000. So this is uh, part A. Part B, among women without breast cancer, that means among women with no breast cancer, it is the sum of 6,944 and 92,256. Then you are asked to find the probability of positive mammogram. How many are with positive mammogram with no breast cancer? They are 6,944. So you will take the ratio of these two. See, among women with positive mammogram, find the probability of not having breast cancer. Now, among women with positive mammogram, which means you will take the sum of 720 and 6,944, which is exactly 7,664. Then from this total, we are going to choose the one with no breast cancer. So the one with no breast cancer is 6,944. So you will take the ratio of these two, so it will be around 0.906. So this is about a good example for computing empirical probability. Now let's see the other type of probability, which is theoretical probability. Theoretical probability is applied in a situation where sample space contain equally likely outcomes and all events are known. All events are known. Okay, so this is theoretical probability. To compute theoretical probability, we are going to use this formula: the number of outcomes in event E divided by the number of outcomes in a sample space, or we use simply n of E over n of S. It will help you to find the theoretical probability. Example, a die is rolled. Find the probability getting a number less than 5. As we know that when the die is rolled, there are six possibilities. There are six possibilities. You can get number 1 or 2 or 3 or 4 or 5 or 6, and each of them have equal chance to occur. Okay, so our sample space will be from 1 to 6, so the number of sample space will be 6, and the event that you are looking for is a number less than 5. So the number less than 5 are from 1 to 4, so the number of event will be 4, and the probability that getting a number less than 5 will be the ratio of uh, the number of event numbers which are less than 5 to the total number of events, so which is 4 over 6 or 2 over 3. So this is the probability of getting a number less than 5. So this is example 2. I think it's better to have more example. Let me add one more example on theoretical probability. Ordinary six-sided dice are rolled. This time we are going to roll 2 dice. What is the probability of getting a sum of 8? So this time we are rolling 2 die, which means that on the first die there is a chance that number 1 can be displaced, and on the second die also number 1 can be displaced. So one possible event can be 1 in 1 or 1 in 2 or 1 in 3, and it goes on up to 1, and the second one will be 6. So total sample space can be this one. Okay, on the first die 1 can be appeared, and the second one 1 also can be appeared, and another possibility, on the first one 1 can be appeared, on the second one 2 can be appeared, then it will go up to 6 to 6, which means that the total number of sample space that we are going to have will be 36, and the event that we are looking for is sum to be 8. Okay, so the event will be 2 on the first one. If it appears 2 on the second one, it should be 6, or if in the first one 3 appears, on the second one 5 must be appeared, or on the first die if 4 appears, on the second one 4 must be appears because the sum must be 8, or if on the first die 5 appears, on the second one 3 must be appears, or on the first die if 6 appear, on the second one 2 must be appeared. So these are the only possible outcomes that we can have. So the total number of E will be 1, 2, 3, 4. Okay, so we are going to have 5 number of events. So the theoretical probability will be the ratio of the number of events divided by the total sample space that we have. So it will be 5 over 36. Okay. Another example, probability and deck of 52 cards. So let's see example 4. You are dealt one card from a standard of 52 card deck. Find the probability of being dealt a heart. Okay, so here, as we know that from 52 card, we are going to have 13 hearts. So the number of event will be 13, and the number of the total possible outcomes, or the total number of sample space is, as you know, it is 52. Therefore, you just take the ratio of 13 to 52, then you will get the probability of being dealt a heart, which is going to be 1 over 4. So this is example 4. Now let's go to example 5. Example 5 is about probability and combination. Florida's lottery game Lotto is set up so that each player chooses 6 different numbers from 1 to 53. If the 6 numbers chosen match the 6 numbers drawn randomly, the player wins or shares to top cash prize. As of this writing, the top cash prize has ranged from 7 million to 106.5 million. With one lotto ticket, what is the probability of winning this prize? Okay, so here we have 53 numbers. You are given numbers from 1 to 53, and you are going to choose 6 numbers from these numbers. Okay, that means one ticket contains 6 numbers. Okay, so the number of ways that you are going to choose will be a combination of these 6 numbers. Since order here, nothing is mentioned about order, so order doesn't matter. So definitely we are going to use a combination in this question. So since the order of choosing the numbers doesn't matter, this is the situation that involved a combination. So if we let E be the event of winning the lottery with one event, so since in one ticket there is only one way of winning, so the number of the event will be 1. And the total number of sample space will be the combination of these 6 numbers. So it will be 53C6. Therefore, the probability will be the ratio of event, which is 1. That means you have only one chance of winning, divided by 53 C6, which is about 20, which is exactly 22,957,480. So take the ratio, which is about you have a winning 1 in 23 million, 1 in 23 million chance you have winning. Okay, let's go to the last point, which is probability of an event not occurring. The sum of the probability of all possible outcomes is always equal to 1. So if we know the probability of an event, then we can determine the probability of an event not occurring. Okay, so the probability of event to occur plus the probability of the event not occur is equal to 1. Therefore, by taking the difference of 1 and the probability of not occurring, you can get the probability of not occurring. So example 6, we have the data here. The data displays about the distribution by age group of 191 million car drivers in the United States, with all numbers rounded to the nearest million. If one driver is randomly selected from this population, find the probability that the person is not in 20 to 29 age group. So here, the total car drivers is about 191 million. So this is the total sample space that we have. And the drivers in 20 to 29 are 33 million, which means that we can easily get the probability of the event. So the probability of not event will be 1 minus the probability of the event the event where the drivers are in age group 20 to 29. So take the ratio, take the difference of 1 and 33 over 191, then you will get exactly 158 divided by 191. So this is about the probability of an event not occurring. We will have more examples during our live discussion. I will stop here about the video. If you have any question, you can ask me during our live discussion. We'll have more example. We'll have more examples during our live discussion. Thank you very much and goodbye.